We've never sneaked a peek beyond the edge of the observable universe. What lies there? If we managed to get there, would we find another universe? What if the universe we live in is just one of billions of trillions of other universes? I'm talking about the concept of a multiverse now. Look, there's this idea of parallel universes. Let's take one of them. It looks exactly the same as our universe, and still, some details differ. Maybe instead of becoming a doctor, you chose to start a music band there. Maybe one infamous asteroid changed its trajectory, and dinos are still roaming Earth in that universe. But the multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities. According to this theory, we live in a bubble that is just one of many other bubbles, which I guess looks like bath foam. These bubbles constantly bob up and vanish. Multiverses are described by a few scientific theories, which mention various possible scenarios, from separate universes that keep springing into existence all the time, to regions of space that are in different planes than our home universe. But there's one thing these theories agree upon. All of them suggest that the space and time we observe is not the only reality. You see, it's impossible to explain all the quirks of our universe if it's the only one to exist. So it's either inventing newer theories that can throw light on certain properties of our universe, or accepting the fact that we're living in just one of many, many universes, all of which are different. One of the most widely known multiverse theories is called inflationary cosmology. This is the idea that right after the Big Bang, the universe expanded rapidly and exponentially. Indeed, cosmic inflation does explain lots of the properties of the universe we observe. For example, the distribution of galaxies. When this theory was suggested for the first time, it was perceived as a piece of science fiction. But it can indeed explain tons of interesting features of the world we live in. So with time, people started taking it seriously. Now, the theory states that inflation might happen again and again, maybe even infinitely. And this could create constellations of bubble universes. Of course, none of these bubbles will have the same properties as ours. There may easily be places where physics as we know it doesn't exist. But even though some of these universes might look like ours, they all lie beyond the realm we can observe directly. Another theory, called the many worlds interpretation, claims that there might be multiple branching timelines, or alternative realities. And in each of those realities, our decisions play out differently, which also means very different outcomes. At the same time, the only reality you can perceive is the one where you live. If it's true, then the question is, where are all those other universes? Well, they most likely all overlap in dimensions we absolutely can't access. And at the moment, it's not possible to travel between universes. But who knows? Maybe a few thousand years later, people will not only find a way to prove that parallel universes exist, but also invent a method to hop from one of them to another. Unfortunately, so far, there's no solid evidence that multiverses exist. All the proof we've got today is purely theoretical. Some experts even argue that it could be an unbelievable cosmic coincidence that the Big Bang created such a perfectly balanced universe as ours. Or, if parallel universes do exist, we might have just inhabited the one that had all the right conditions for our survival. It's still unclear whether the multiverse theory is even testable. Perhaps we just haven't thought of the right tests yet. Now, I've got one scary thought for you to consider. What if, at one point, you stopped existing in your home universe, the one you were born into? What if your consciousness was transported to a parallel universe, where you're now watching this video? Think of this. 13.8 billion years ago, a mysterious explosion happened in space. It was chaos, a time when the stars, planets, asteroids, the rest of the space bodies, and galaxies were born. It was the Big Bang, a theory we all know about. But no one knows for sure what happened, where the universe came from, and what was there before. Some even think the universe went through a cycle where it contracted and expanded several times. In 1991, a cosmologist from Stanford University named Andre Linde had submitted an article with the main idea that there was a possibility the universe had been created in a laboratory. His theory said there was a chance an advanced civilization somewhere out there had created our universe. This civilization has made an entirely new cosmos, that later evolved its own planets, stars, and intelligent forms of life. 30 years later, many scientists take this theory pretty seriously. They even started talking about things that we, as a civilization, can do to get to such an advanced level. The theory says this advanced civilization decided to add technology that helped to create a new universe out of nothing. It happened through quantum tunneling. It's when an atom can appear on the opposite side of some barrier, even though it's supposed to be impossible, considering the laws of physics of our world. Like if you wanted to pass a tall wall, but you can't pass it with ladders or go around somewhere. Imagine you can just walk through it like a ghost. In our world, it's not possible, but a more advanced civilization perhaps can do it. Plus, they realized how they could create new universes. Right now, on the cosmic scale, we could be a Class C civilization. We don't know how to recreate some things. For example, conditions on the Earth for when our central star, the Sun, goes out. If we manage to become a Class B civilization, we'll learn to adjust conditions to be independent of the Sun. That means we might be able to learn how to live even without it. And if we level up and become Class A, we'll know how to recreate cosmic conditions and produce our own cosmos in our laboratories. We think of the world we live in through 3 dimensions of space: east, west, north, south, and up, down. There's also 1 dimension of time, which means we can distinguish past from future. A 5th dimension would represent 1 more extra dimension of space. The theory of its existence was first mentioned in the 1920s. It was inspired by the theory of gravity by Albert Einstein, who said space-time is warped by matter and energy. We can't perceive these 4 dimensions, but we see how an object moves and attribute it to gravity. And maybe there's some other force, like the electromagnetic force, that's more than 1,000 times stronger than gravity, that could explain things going on in that extra dimension of space. The 5th dimension is curved in a way we can't see it, but the idea about it was mentioned in a string theory. It considers the universe as really small strings of mass energy, not as particles. They vibrate in 10-dimensional space-time, considering 6 dimensions are rolled up way smaller than a single atom. That led to the picture of the universe as a 3D island that floats in 10-dimensional space-time. Also, the 5th dimension might be an excellent explanation to tell us more about dark matter. That's the invisible stuff with a mass, but we can't see it, nor can it interact with ordinary matter. And dark matter is 85% of all the matter in our universe. The universe can't be still. It's constantly in motion, either contracting or expanding. We used to think there were 100 billion galaxies, but it turns out there are more than 1 trillion. The galaxies are moving away from each other. This is what it means when scientists say the universe is expanding all the time. There are voids between galaxies that sometimes stretch millions and millions of light years across. They can seem empty, but they can also contain way more matter than we can find in galaxies. Still, stars usually can't be formed there because the matter between those areas has lower density. But there's still plenty of so-called intergalactic stars. A good example is the VIRGO galaxy cluster, 10% of which are intergalactic stars. We don't know how exactly they got there, but there are 2 possible ways. 1. Stars can collide, merge, or pass close to another galaxy, which can kick it off from its parent galaxy. Option number 2. A supermassive black hole can accelerate a star to very high velocities if they have a close encounter, which can, again, make a star be expelled from its parent galaxy. If you could have a giant magnet, you could even pull something out from the vicinity of a black hole. That's possible if the magnetic field near a supermassive black hole is as strong as the black hole's gravitational field. But it doesn't work if we're talking about material that's already beyond the black hole's event horizon. That's a spot with a gravitational force so powerful, not even light can get away. You'd need to accelerate this material to the speed of light, at least, to get away. For that, you'd need an infinite amount of energy. But a magnet could help if something's heading toward the black hole but didn't get inside yet. When someone mentions a black hole, you might get a picture of some giant void in space, but the Milky Way is most likely full of thousands of smaller black holes that float around the galaxy. When a star comes to its end, it will destroy itself in a supernova explosion, which is a cataclysm of energy. In that explosion, the densities in the core will reach an intense enough state that nothing will be able to escape. At the same time, the major part of the star explodes outward, but a part of it collapses inward, creating a black hole. The bigger the star, the bigger the hole. The black hole then swallows everything that comes in its way, including other stars as well. When a star gets sucked up into the black hole, it's ripped apart because of the strong gravity inside the black hole. Some of its parts fall into the black hole, while others get ejected at incredibly high speeds. Some black holes might have been formed in a different way. The early stages of our universe were, to say the least, pretty chaotic. It had high temperatures and pressures, and was in a state that shaped the entire cosmos. Under the right conditions, any old gas patch may have shrunk itself to become a black hole. And they came in many different sizes, from something that weighs a couple of pounds to giant masses like thousands of suns, and those in between. They aren't really black. Black holes are areas with strong gravity, and no object can escape when it gets inside. They feed off electromagnetic radiation, such as light and space particles. Since they're consuming matter all the time, black holes give off a dark glow. The Earth is not that close to the inhospitable edge of the solar system. We're the 6th planet from it. Scientists made a pretty cool 3D map of our solar system, where we can see what the edge looks like. It took them 13 years to design it. The boundary is called the outer heliosphere. It marks the area in space where the solar wind, which is the stream of charged particles our sun emits, gets deflected and draped back by the radiation coming from the empty region beyond our solar system. The inner layer of the heliosphere is where the sun and the planets have a rough shape of a sphere, while the outer layer is not that symmetrical. This asymmetry happens because our sun is moving through the galaxy and goes through friction with the radiation in front of it. We fly away from Earth to look at it from a distance. It glows like a holiday tree. Big cities look like yellow spots at night, and during the day, we see strange structures, like a palm tree-shaped island in the UAE, or a dark band that runs all the way through China, the Great Wall. These are traces of human existence. Now let's point our telescope at other planets. Mars, it's just an empty, endless desert. Venus, only rocks and volcanoes. Even if we look into distant space, all the planets out there are deserted and lifeless. Not a single trace of an extraterrestrial civilization. Many people are convinced that life on Earth isn't unique at all. Here's our galaxy. There are billions of sun-like stars. And here is the entire observable universe with billions of such galaxies. There's an almost infinite number of stars, and near each of them, there may be habitable worlds. But we may not have found life on other planets because it hides from us under the surface. For example, there's Europa, a satellite of Jupiter, slightly smaller than our moon. Its structure resembles a soft-boiled egg. Its surface is a hard crust of ice, but if you take a big enough drill, you can get to the liquid yolk, an ocean of water. Jupiter and its satellites are very far from the sun, so it's quite cold there, about 270 degrees below zero. So liquid water instantly turns to ice. But Jupiter has a strong gravitational force that causes a lot of friction inside Europa, and its core heats up. The heat melts the ice, and we have a watery ocean under the surface. Water is the foundation of all life, so there could be simple bacteria in that ocean. And who knows, maybe there are other life forms out there. For example, weirdly shaped fish. Because of the weak gravity, their bodies are built differently, or something like whales feeding on plankton. In 2009, scientists found a planet that is completely covered by an ocean, GJ 1214. It's about 40 light-years from Earth, and about 75% of its mass is water. Still, the temperatures on this planet are so high that water evaporates and takes the form of super liquid water. There's so much steam that it feels as thick as water itself. No life could exist in such conditions. But scientists have recently found at least 24 planets better than Earth and called them superhabitable. These planets orbit distant stars in their habitable zone. It's the sweet spot at a perfect distance from the star. In our solar system, Venus, Earth, and Mars are in this zone. A superhabitable planet must be 10% larger than Earth and have stronger gravity. That way, it can have a denser atmosphere. A temperature 8 degrees higher than on Earth would make the planet more humid. This would encourage a variety of living organisms there. These planets may be great for life, but it's hard to tell if there is life there already. The main marker that would confirm the existence of an advanced civilization there might be radio waves. Imagine a habitable planet similar to Earth. In the process of evolution, intelligent beings appeared there, like humans. They're much taller because of low gravity, and their eyes are adapted to the light from another star, much brighter than the sun. Sooner or later, this civilization will have to use radio waves to communicate with each other. We can think of these waves as loud sound from speakers. Here's Earth. We're now actively using radio waves, and the noise coming from our planet is pretty serious. If a neighboring planet had radio telescopes, big dishes that catch these waves, they would realize that life is blooming here. There are many radio telescopes on Earth that are pointed into distant space, waiting for a signal from aliens. But we haven't received anything yet. Still, that doesn't mean there isn't a planet somewhere in the universe that emits radio waves. It's all about distance. We're jumping 200 light years to another star. Suppose there's a planet X where life exists. The civilization here is advanced enough to use radio waves, so they release the first wave into space. Our radio telescopes won't be able to pick it up until 200 years later. This also works the other way around. Radio communication on Earth has only existed since 1895. Our radio signal won't reach Planet X until 2095, and only then the aliens will hear our voice. But this radio noise doesn't stay for long. Every year, our technology improves, and our radio noise decreases. We're beginning to use mobile communication, cable TV, and fiber optics. This all reduces the volume of our planet in the radio spectrum, and soon it will simply become invisible to other planets. The same thing is happening on the other side. So, the radio waves coming from civilizations are a brief blip on the cosmic scale, and we can't accept radio silence as proof that extraterrestrial life doesn't exist. A giant telescope, which could take a direct photo of a possibly inhabited planet, would change the situation. We zoom in on the photo, and there it is! We see alien cities with tall buildings and lots of antennas. But now, we can't look that far away. We can take pictures of Mars and its satellites, and even their quality misleads us. For example, Cydonia. It looks just like a human face on Mars. We thought there used to be an ancient civilization there that made some sort of sculpture or memorial. More extravagant theories said it was the remains of a giant human, and there's a whole body of it under the sands of Mars. But in fact, it was just a hill. Strong winds blew out some hollows there, and when there was a shadow in those hollows, we took them for human eyes and a mouth. Or a monolith on Mars's satellite Phobos. We found a smooth rock there that was almost as tall as the pyramid of Cheops. The news has spawned many theories about the civilization that built it, but it turned out to be no more than a rock. The infinite number of stars and worlds around them almost guarantees the existence of other civilizations, so why wouldn't they come to Earth, right? We think that life throughout the universe develops in similar scenarios. The emergence of simple life forms, followed by evolution, and growth of a technologically advanced civilization. But, just like on Earth, cataclysms happen there too, causing mass extinctions. Meteorites, for example. Perhaps there was a civilization out there ready to go into outer space, but a huge meteorite, like the one that wiped the dinosaurs off the Earth's surface, made that civilization disappear, and life on that planet began a new cycle from scratch. In addition, the more advanced the civilization, the greater the risk of its self-destruction. Scientists might conduct experiments in machines like the Large Hadron Collider and accidentally create a black hole there. It would begin to swallow everything around it and grow in size. Soon, all the super-developed cities of this civilization and the entire planet would simply disappear. Another possibility for super-advanced civilizations is to travel through wormholes. Those are tunnels in space-time between universes. Aliens might travel through them and lose interest in going back. But it's also possible that life on Earth is unique. That's because our planet was formed thanks to a number of incredible coincidences. The first is the location of our solar system in the galaxy. In the Milky Way, there are constant fireworks of exploding supernovae. The radiation from these explosions destroys everything around it at great distances. Our solar system is right in the sweet spot of the galactic orbit where we're safe from such explosions. Another factor is the moon. One theory of the formation of the moon says that about 4.5 billion years ago, a meteorite the size of Mars crashed into us. If the impact had been straight, the Earth would have just broken apart. And if that meteorite had only scratched the Earth, the pieces would have just flown away. But the collision occurred precisely so that part of the meteorite remained in Earth's orbit and formed the Moon. Then, the Moon stabilized the Earth's rotation and heated our core with gravity. Only then, our planet developed a magnetic field, which protects us from the solar wind. Other scientists believe that life outside Earth may be biochemically different. Carbon and water are the basis of our bodies, but carbon could be replaced with silicon or phosphorus, and water could be replaced with ammonia or methane. These atoms could form molecules of different shapes and perhaps assemble into a living organism. Life based on such elements would be unlike anything seen on Earth.